All right. We got some people in the room now. Might have some more join, but I'm not sure how long this will run. Might run long, right? Might run short. So I figure we jump right in, right on time here. So thanks everybody for joining that has. My name's Troy Daniels, head of technical training here at SimpliPhi Power. We're going to be talking a little bit different today. We're going to be talking this one really does focus around some more recent events and trying to hone in on that and look at some solutions, hopefully, that can take place in lieu of these not so great events that have happened. So today we're going to be talking about power outages and building resiliency from distributed assets, housekeeping wise, Q&A. If you have any questions, type them into that little Q&A bar at the top. So if you scroll over your control bar, you'll see Q&A. You can type in questions there. We will go through them at the end. For anyone that's attending this presentation that has not ever sat through one of my presentations before on SimpliPhi, we're going to go through a little bit of basic stuff as we always do. But this is a bit more generalized, so I'm not going to jump too much into our stuff as much as just talking about solar and storage and distributed assets in a generalized term. As always, please subscribe to our IQ newsletter for all things training. And don't forget to check out our training calendar if you're not subscribed to the newsletter to see what's up and coming. We've got some exciting stuff on the horizon. I think next one, Victron Energy, we're going to do another training with them around mobile applications. So those ones are always fun. All right. With that being said, let's jump right in. So I know if you've sat through my slides, you've seen these few beginning slides, but I got to do them. And I really think they set the stage for this presentation as well. SimpliPhi Power. What are we doing here? Safe, proven, simple technology. Safe as its non-toxic, non-hazardous chemistry using lithium iron phosphate. This is cobalt-free chemistry, so there's no risk of thermal runaway and fire propagation. UL certified 1642, 1973, so 1642 being cell level, 1973 being the battery level, 9540, the newest edition on a kind of a system level. And if you need more information on that, I know that's becoming kind of a hot topic. Reach out to us. We can direct you to which units are 9540 that we put together. And 9540A is not a listing, it's a test protocol, but we're going through that as well. UN DOT certified 3480, 38.3. We're actually SCHIP approved if you're in California. Proven technology, to just kind of sum it up, we're in over 40 countries, well over 100 megawatt hours at this point, worldwide deployed. We've been tested and validated by the US Army and Marine Corps, and we actually manufacture in the United States. So pretty rare to find. There's a lot of white labeled batteries out there. We are still working to manufacture in the United States and build growth here. And really try to keep things simple as possible. How do we integrate our chemistry? How do we integrate our batteries into as many solutions that make sense as possible? Okay, so let's talk a little bit about this. I've actually presented on this slide before, but this slide makes the world of difference here. We're definitely talking about these specific things, and we're going to talk about an example being the recent-ish Texas outage that really makes, puts this all in perspective, that this is truly a problem. So looking at escalating energy costs. So US residential electricity prices have risen by 15% in the last 10 years. That's going to continue. I don't foresee that that's going to go anywhere down. At least it's going to continue to continue to go up. So hopefully we can bring it down with renewable energy and distributed assets. Failing infrastructure. This is huge too. This is what we're going to talk about today a lot. 2010 through 2019 marked the costliest decade on record with economic damage due to severe weather, reaching 2.9 trillion. So, this is a lot has to do with our infrastructure and old failing infrastructure, and looking at how to fix that. And as always, decarbonization always still important to us as a company. really cutting down on that footprint the best way we can. Okay, and also on a little bit of a side note, I'm going to just go through this, various applications, I think, and we're going to talk about these, but just to kind of give you a rundown so we don't have to extrapolate them too much as we go through it. These applications can tie right into, I guess, how I see it as these are issues that we're seeing. So as far as financial issues, when it comes to what customers are being charged, that being said, these can be a great tool, or batteries can play a great role as a tool to help mitigate these kind of things. So peak load shaving, for instance, the idea that you're getting charged more at certain demands. So, you need to use this much power. You get charged more above that threshold. I see this a lot in commercial. I think some people have been talking a lot residential wise on this, but I really just see this on commercial level stuff. But a battery can take care of that. So when it hits that peak, you tell the inverter to start discharging battery. The electric company is none the wiser as far as if you actually use that peak or not. Time of use, I'm sure most, if not all, are familiar with this at this point. It's continuing to happen. It's continuing to become pretty specific around the United States. So, hey, you get home at 4 and the peak demand charge, so they're going to charge a little bit more from 4 to 6. When you're using the most power, they know when you're using the most power and they're going to charge you for it. A battery, again, especially mixed with integrated solar plus storage, which I'm going to next, can mitigate these factors dramatically. If you're, selling systems to people, it's a great sales tool when trying to add battery and storage. So again, that's the integrated solar plus storage, the idea of, as I look at it, owning your own power, using your own power, using your own production more than anything. Okay, so let's talk about this recent event, the power outages in Texas. So winter storm caused extreme infrastructure failure, leaving millions without power. Let me just make sure everything's awesome. Okay, just checking the Q&A, making sure my audio is okay and everything. 50% of all generation in Texas, these are 350 individual assets, failed during the storm. This is an outdated power grid. And this is what caused this grid to remain down for such an extended period of time. So looking at the Texas power grid, it's actually independent, not federally regulated, therefore not forced to be winterized. They can't borrow or sell power to states. And looking at the breakdown here, 47% natural gas, 20% wind, 30 wind and PV, both combined, 32% nuclear, coal, and other. Many natural gas plants were not operational during the storm, as well as many wind turbines. Overcast conditions reduced PV production as well. So again, we're looking at a massive failure here, and looking at what that caused. I think we're going to talk about it a little bit more later, but as far as the implications go, as far as what it caused, but really, when you look at it, we are not just looking at safety concerns with losing power, but the aftermath as far as financial repercussions was large as well. And that was not just on a large scale. So, the power company or something sees those issues, they pass it off to the customers. And I'm sure we've all heard the stories by now of, customers receiving huge bills during times they didn't even have power. So definitely a lot of repercussions there. The good news, as I always see it, is what can we do? How can we fix that? I think first we need to look at solar without storage and really understand the limitations that I know most of us probably know, but I think the mark is often missed when it comes to customer education. So solar without storage, we're talking grid-tied solar. This comes at a super affordable price and a ton of different variety when it comes to how to purchase, leasing, financing, buying outright. These options are flexible and they're easier. They become easier and easier. The prices come down of solar dramatically, as we all know. Hell, I think when I started working for for in this industry in general, it was like $5 a kilowatt, so, or excuse me, watt, and it's gone down drastically, as we all know. So solar by itself, grid tied solar, is extremely affordable now, I think. I mean, maybe others might disagree, but I think from where it's been, it's affordable. And these options really can help customers purchase it very easily. It can often completely cut out electricity bill in a lot of cases. I've seen that. So, you might be replacing it with maybe, let's say, a leasing bill, but now you're just paying for solar instead of paying for the electric company's, coal production or whatever it is they might be using, natural gas, things like that. What do the customers typically not understand about grid tied solar? And this is a generalization, so it's not always, but it's been from my experience, this is what I find customers to not understand. The biggest one being solar production will not work during outages, and customers will lose power the same as any other house, with or without a PV system. So, I know my time in the grid tied industry, I often would get calls saying, hey, why did I lose power when the power went out? I thought I have solar panels. Well, as we all know, they're not operating when the power is out, not in a standard grid tied system. Having just PV by itself, so just a solar system, typically, not always, it can, but for the most part, will not protect a customer for things like peak demands and time of use. It definitely, at the very least, will definitely not help people when it comes to like reactive time of use. So being, hey, make sure that there's some kind of storage in place to discharge from 4 to 6 so I don't get charged with that bill. If you're just relying on solar to make sure that you are using not using the utility during that time, that's a variable, and that's very hard to determine. So it might just happen naturally, but it's not to be relied upon to deal with mitigate these demand charges. And kind of just thinking like in general terms, I always say own your own power. Well, I think this is a great example of saying, looking at how you don't really own your own power. Let's say you production in the middle of the day when you're not using loads, maybe you're at work. Well, that's just being sold back to the grid. And when that's the case, you're really not storing it, you're not using it, and honestly, any excess you're not using as well. So that's kind of how I see the limitations here when it comes to solar by itself. The great news is storage is coming down in cost as well. It's becoming readily available. There's more options. There's even financing and things like that through different companies these days. So looking at solar with storage, we're talking about adding a battery. Plus, I think something we kind of look past, the most important part, I think, is the corresponding electrical equipment, such as an inverter and charger, that really is the lifeblood of how to function and how to control your battery and your PV, frankly, in a manner that allows you to do so much more with the system. For instance, during a power outage, a customer can utilize battery power to cover critical loads. This is almost always set up automatically in these kind of inverters, a seamless transition during an event. So, automatic transfer switch built into these inverters, power goes out, your critical loads are covered. So often the inverter system itself, so again, this is needed in a battery system. And if you're looking at ESS, all-in-one solutions, it comes with everything. These inverters can act as a temporary signal to bring back online that grid-tied PV. So not only do you end up with battery backup. So let's say you've got 10 kilowatt hours of battery backup, and maybe you're running a kilowatt of loads at a time. So you factor in, hey, I've got I'm running 1 kilowatt of load, which is maybe a lot for your home, maybe a little, who knows. You got about 10 hours of battery power. The cool thing is when you're doing solar plus storage integration, again, we can bring that PV back online. So if the power is out and the sun is shining at all, we have some production. We have the ability to recharge the batteries, to cover loads with some excess PV. it's a mini island mode, common phrase. That's how I look at it. You're building your little mini grid here. You're self-sustaining a little bit more than you were before. You're definitely more self-sustaining than just having a PV system by itself. Some other benefits: a battery system adds the ability to self-consume power generated by storing it. Thinking about when a customer actually has the need for this and the ability to sell back to the grid still. I think that's a misconception. People often, think about, oh, well, if I have a battery, I won't be selling back to the grid. I won't be getting these credits that I typically get. If you charge up these batteries, for instance, lithium iron phosphate, our batteries have very low self-discharge rate. So if they're charged up once, they're going to stay charged up for the most part if you're not using them. So really, you charge it up once, you're still selling off any excess power like you normally would. And this doesn't affect that, other than when you need to charge the battery, or if you want to use the battery in a manner that, it discharges it so that it needs to be charged again. But again, you have this ability to self-consume and use that battery when you need. This can be done through things like grid use timers. Again, if you're DC coupled, which we'll get in a little bit more specifics there later, you can do things like time of use, like I mentioned, and just the ability to naturally store that power that you're not using and store as into energy storage, into something clean, and discharge it when you want to use it. You've got a lot of control this way. Some systems are even capable of financial safety from increasing rates. Again, that's things like demand charges, such as peak load and time of use. So it's definitely a bit of a financial protection there. And I think really it's a financial protection when you look at it is in rising cost, not just standard utility costs, not going from 12 cents to 20 cents. Thinking about time of use, maybe that rate goes up, maybe it extends. You can definitely help yourself when it comes to having that storage, peace of mind, financial security. Okay, so what is a distributed asset? Well, I use that word a lot. I've definitely used it already a few times now. So what is it? A distributed asset, at least in the context we're talking about of this presentation, is referring to a battery-based system. This can include the production and the storage. And as I look at it, really, we're looking at like a residential system, at least for this presentation. You could argue so many things as far as what's a distributed asset, but what I'm talking about is really your distributed asset is your little island that you've built. And what's the point of it? Why are these so important? Why do we talk about it so much? It has numerous benefits, but looking at some of the big ones here, cutting down on grid reliance, huge, and actually really taking off some of that pressure off the grid, really. The more distributed assets, the more pressure is actually taken off the grid. And if the infrastructure is not the greatest, you're actually helping the infrastructure out a little bit by having a distributed asset like a battery and solar in your home. A reactive power, this is something you're going to probably hear more and more of in the future. Some people probably already know it. Definitely if you're in Northern California, you might have already heard this, especially with the fires that have happened. The ability to actually use your distributed asset on the electrical company's front. So saying, hey, we know that a lot of power needs to go here, and the ability to actually discharge your battery onto there. Now, I've got mixed feelings there. It's your asset. I think you should be able to use it as you want. And I think there will be kind of things in place to help with that. But, they would be buying that power technically from you. It would be the idea. There's an environmental impact as far as good with distributed assets. So cutting back on that centralized grid that typically does not use renewables. And again, just energy security. I mean, it's the easiest way to put it. That's the ability to know, if you're in Texas and that power outage happens, you at least have that backup ready to go. Maybe you do need to charge a little bit from a generator, or hopefully, your PV can do some production during that long outage. But just knowing that you have that power available and that your critical loads are going to be there, and really looking at how to understand your critical loads in the sense that, hey, I only have this much power. What can I use that is really critical? I'm actually going to be doing a presentation, I believe next month, or I think it's next month, around backup, and kind of similar to this, but really just like really kind of rolled into a little bit more about backup power specifically. And we're going to be talking with Lumen's going to be on the presentation, I believe, or at least we'll have some slides. Look at these smart panels. These are something I really like to think about when it comes to power outages like the one in Texas, where it's really long. These smart panels will help you kind of gauge how much you're using, turn off loads as you see fit. Just makes it really smart system that can get you through really tough times like these. PV comes back on, start turning back on more loads. So it's just a really cool system. And again, if you're interested in that kind of stuff, I would definitely sign up for that presentation coming up. Okay, let's get into a little bit of the nitty gritty stuff, the installation stuff, and just talking a little bit more through what exactly is happening. So we're talking here about adding storage to a grid-tied PV system. How do we do it, whether it's new or existing? Some key definitions here: AC coupling AC power from, actually, I think looking at coupling as the main definition very first. Coupling is, sorry, I think there's two slides here. That's strange. Okay. Coupling is really the idea of how your PV is connected to your battery. At least that's how I'm going to use it in this sense. So AC coupling is, PV power is immediately inverted to AC before reaching loads or battery-based inverter. From there, power can either go directly to your loads, the grid, as AC power, or be converted back to DC for charging the batteries. This is what I would call the retrofit solution oftentimes. DC coupling, this is DC power from the PV array with charging regulation in order to charge a battery bank before ever being inverted to AC. I find this way to be a little bit more efficient. People look at DC coupling oftentimes as off-grid only. Not true at all. You can definitely go grid tied as well, and it's a really nice system that allows for some really nice functions. I would say this is not typically the solution I would ever go with if a PV system is already in place, grid tied. If you're really interested in all things DC AC coupled, I could talk for hours on it, and I do. So check out our AC DC coupling webinar we have. We actually have one coming up, I believe, in 2 weeks. So check that out. That's always really good to dive into the specifics there. Critical load panel, often the definition we're going to use here as well. Might be called the backup load panel, whatever you want to call it, whatever the right term is now. This is just an additional AC panel added to a home that contains loads deemed critical that can only be powered during normal operation, or can not only be powered during normal operation, but also be powered during grid outage. Some people do whole home backup situations, but this makes a lot more sense always. Even if you move all your loads over to your critical loads panel, it's the way to go. Frequency shifting, the last thing I'll mention, because this might come up here as we go through these slides. It's just a mechanism used by the battery-based inverter to curtail or operate PV production during a grid outage. It's what keeps those inverters online, keeps PV production going. So let's say we're adding storage to a grid-tied PV system, something that's already in place. SimpliPhi offers a ton of solutions when it comes to that can be utilized to add a battery to an existing PV system. Some installers might choose to purchase the batteries and inverter not as an all-in-one. So they're putting their own building materials together, and they know what they're doing, and they want to use a specific inverter, and our battery, and put everything together. This does allow for greater flexibility regarding sizing and what loads can be backed up. Whole home backup, you can build it out with this kind of solution. If you know what you're doing and you know how to put everything together yourself and integrate everything, you can do some pretty wild systems. And it can often cut down on cost, as building everything together does have a cost associated with it. However, we do offer ESS solutions, energy storage solutions. So you can see here our access unit on the right. This is our all-in-one inverter charger, batteries built in the NEMA 3 enclosure. That's a benefit right there, is often it's ready to go, outdoor rated, so that you can just slide it outside wherever you need it. This can cut down on installation time greatly. And it's a great choice for installers that are just getting started with storage. So maybe you've done a ton of grid tied in the past, and now you want to add storage to your repertoire. Well, this is a great way to do it, and to kind of have an easier way in. One thing I'll mention when it comes to our ESS solutions, at the very least, when using time of use, so if that's the function that your customer is asking for, I would not go with AC coupled. Solarc, the Solarc access does say they can do time of use with AC coupled. That's the only one. So if you want true time of use function, DC coupled is actually the better way to go. As AC coupling, you're often just using grid use timers versus true discharge, self-discharge time of use. So just keep that in mind. Okay, so I know this is kind of a lame little chart here, but here's your grid tied PV. You know, you've got your solar panels, your microinverters, your critical loads, or your critical loads panel, your main loads panel, and often that critical loads panel might just be a combiner for the PV itself, and out to your grid. If you're using one of our ESS solutions, all you're doing is throwing that right in the middle there. Obviously a little wiring, but you are basically just running, you're just kind of cutting that line right there. You're jumping in between a critical loads panel here and the main loads panel. Now, when the power goes out, this will cut, you'll be in island mode, and everything on your critical loads panel will be powered, as well as your PV will be back online to perform production. That's definitely an easy solution as well if you're just putting it together. This is actually, so like, let's say you had a big system, maybe you wanted to cover a lot. Obviously this is a small panel. Let's say this is a 100 amp panel and they want to cover a lot of loads and make sure they have tons of backup. You might be able to put in your own inverter that you want as an installer. These are our boss cabinets that are just outdoor rated cabinets for our batteries. Maybe, you know, you've got 212 cabinets, so you've got a ton of backup. The idea being here, though, our solutions are flexible. So if you want to build something bigger for a customer, that's what they're asking for, we can definitely do it. It's pretty easy. Okay, so when adding storage, I'm going to go a little opinion-y here. This is my own opinion, just so you know. But when adding storage and PV at the same time to a grid-tied system, I typically would recommend going DC coupled if you're comfortable with it. I think there's a lot more functionality when it comes to a battery-based DC coupled system. It allows for better utilization of features like time of use and peak load shaving, as I already mentioned. Charging from a charge controller versus converting back from grid-tied PV is actually more efficient and more dynamic use of the PV system. Can use the charging algorithm better, less sensitive. Charging is not interrupted at all when the grid goes down. I mean, it's just, you know, it doesn't even notice basically. System can still sell just as a grid tied system would, just as an AC coupled system would. Self-consumption can be used more seamlessly, even when the grid is still present. So you can say, you know, hey, I want to discharge my battery first over the grid without having to use grid use timers and things like that. Something to also think about if you're putting, and this actually applies for if you're putting an AC coupled system in or a DC coupled system in from scratch, but with a battery right away, you're eligible for the ITC credit towards the battery as well, if 75% of it's charged technically from renewables. I'll be honest, I'm not the best when it comes to policy. I don't know exactly how that's determined, but I definitely know lots of people that have made it through that and been able to apply their ITC credit to battery and solar production. So just an idea of a DC coupled system. I'm going to use the Solarc. It's a great example because it has a charge controller built into it. But, you know, here's, let's say, your PV panels. These are, let's say, fire safety shutdowns. So that's maybe like, I think these ones are the Tigos I got in this picture. So those are just for NEC requirements as far as rapid shutdown goes. But let's say we're going into a charge controller here. So this is still DC and it goes right into these batteries. So maybe you, again, want a huge bank combined here. You got a ton of battery storage here. And now your critical loads panel is still set up. Your main panel is still set up and the grid's still there. So again, it's just more of a functionality thing. That being said, if the PV is already in place, and you're going back to a customer that you've already installed a system for grid tied, this is not going to be the solution because you're going to have to rip out a lot of things and rewire. But if you're from scratch, DC coupled awesome, especially with these new charge controllers they're building into these inverters that are typically higher voltage range, so you can still run some pretty large strings. Okay, well, we actually did great on time. We're like 30 minutes, pretty short speech. I did want to go ahead and mention, especially for anyone that's on that is already installing our batteries, I just want to urge you to really apply for our Elite Installer Qualification Program. So become qualified. Distributors are going to keep doing this as well. It increases their sales. They want people to know who in their network has gone through this program. I want to be very clear for anyone new to our company. This is not a requirement to install our batteries. You can install our batteries, purchase our batteries without being part of this program. It's for people that have already accomplished 2 installations. They should join this program. You will end up on this where to buy page on our map. So if somebody's looking for an installer in their area, they can click on your little icon there and see that we trust you as an installer and you've gone through this program. Again, not a requirement to install our batteries, but a huge benefit for those that are already installing our batteries. So if you are, it takes like 5 minutes to fill out the application. We'll get you all set up on the page. You'll end up probably on our IQ, Elite IQ newsletter. And we're going to be inviting some of these IQ installers on to various podcasts and things like that we're doing. Just as a plug, Matthew and myself, Matt Walker, our other trainer, just finalized our what's going to be our new podcast, basically, where we're going to talk things batteries, no video or anything, just us talking back and forth. First one surrounded about wind energy a little bit and some of the misconceptions there, as well as just frequently asked questions. That should be live at the end of this month, I believe, or maybe start of next month. Don't quote me there, but keep an eye out for that and definitely apply for our IQ newsletter to get an idea of when that's coming out. So again, if you're already using our batteries in systems, you've already done some installs or planning on doing installs that you know we'll be going through soon, go ahead and submit an application, follow that link. It's on our website. Go to go to training, IQ qualification program. Check it out. It takes 5 minutes to fill out the application online, and we'll get you all set up with that. Okay. I just want to remind everybody, if there are any questions, I see just a couple actually. Go ahead and type them into the Q&A now. We are just at the end, so I got some time here to run through questions. Okay, first question. Is it possible to get this presentation? Yeah, I just recorded and we'll send out, everyone that's attended will get a link to the recording of this presentation, as well as if you need some other material, you can respond there as well. We have a home in San Antonio area and we are considering solar with some batteries to enable using the solar generated power. What is the minimum we would need? Tough question. Question comes up a lot in this industry in general. It just depends on your needs, what you're looking for. I mean, I've seen people get away with 2 batteries and that's all they need to get through, 2 days of critical loads. And I've seen people need 30 batteries because their house is large. They want to back up a lot of critical loads. There's also a financial aspect, hey, I can only afford 3 batteries. Well, the good news is you can cut back on your critical loads a little bit there too, and also factor in your solar. So if you're really interested in getting some kind of system put in place, you can either reach out to us and we can try to connect you with one of our installers in the area that we know are using our batteries. Check out our IQ page, see if that where to buy map and see if there's anything there that might fit close to your area that we have used in the past. But we're happy to help find you somebody. So just reach out to our sales number, sales@simpliphipower.com. So same as this, training at SimpliPhi Power, but sales at SimpliPhi Power. One of our sales application engineers will get you set up. We need to support a 3-phase well pump. Is that possible? Sure, it's possible. 3-phase is tricky. So if it's true 3-phase where you actually need that 208, sometimes you'll need 3 inverters stacked to form that 3-phase. But just talking on the battery front of things, it doesn't really matter when it comes to the batteries. They're just the DC power. So what comes out of the inverter is more important on that kind of front than what's on the other side of it. If you need a 3-phase solution, you might not be able to go with an ESS solution, just an all-in-one built-in solution. You probably need to look at putting together a bit of more advanced build of materials. Again, if you're interested and need some help with that, reach out to us. We're happy to help there, and at least point you in the right direction of some inverter manufacturers that can help you out too. I am planning to take this certified installer training, and I would like to know if you have a design review department. It would be great to have the single lines checked before moving to installation. Absolutely. If you've got designs already put up, they're not going to build you single lines. I'm just going to be honest with you right now. Sounds like you already have some designs and some questions. Again, reach out to sales@simpliphipower.com, or just call us, and I believe it's prompt 2. If you hit sales, you're not going to get a sales member of our team. You're going to get a sales application engineer that knows what they're doing and can help guide through system design, look over single lines, things like that. So yeah, reach out, please. We're happy to look. Actually, I would say, coming from the support side of things and the training side of things, I would rather you reached out definitely in the beginning, now especially, than just put in the system and look at it later. We're happy to help and make sure everything's right now before it goes in. Any battery heating in outdoor enclosures. So there's not in that standard enclosure. There's definitely some heat coming from the inverter itself. We do have a heating solution we've used, and we've got some further stuff on the horizon when it comes to battery heaters. But if you really need that heating solution now, just again, reach out to, I keep saying it, but reach out to our sales and they can help you direct you in the right direction there for a solution to provide that ESS solution with a heater. All right, looks like we are just about out of questions there. So again, I just want to thank everybody for joining. One more plug again, if you're looking to join that IQ qualification program, you're already installing our batteries, and you have any questions about applying, you can't find it where you need to go, shoot me an email at training@simpliphipower.com. I'm happy to help anytime. All right, big thanks for everybody one more time. Oh, one more. I am a NAPSEP certified installer. Does this installer program include a training program? What does it look like? Yeah, there's a few trainings actually that are kind of put together with this. So there's my battery 101, the NAPSEP, or they're all actually my NAPSEP credited trainings. The battery 101, the charge and discharge characteristics, and the AC versus DC coupling. Those are 3 required trainings to become part of the program. We do allow for you to just watch them on YouTube and kind of Scouts honor there. But if you look at our page on the application for the IQ program, you'll actually find a list of those 3 trainings as well as links to watch them if you haven't already. So, or again, I'm happy to help. So if you want to reach out direct, training@simpliphipower.com, happy to help there. All right, everybody, really big thanks again. You'll see a follow-up with some more information as well as the training itself recorded. So thank you, everybody. Have a great day.